In addition to simplifying radical expressions, it's also important to be able to do algebraic operations like adding and subtracting and multiplying. And so that's what this video is going to cover today. If you notice at the top of the video it says perfect squares, because our list of perfect squares is going to continue to be the main thing that we're going to focus on. That's going to help us simplify things. So our list of perfect squares: 1, 4, 9, 16, 5 times 5 is 25, 36, 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 121, 144. I could keep going from there, but I think that's a good stopping point. We need to remember stuff from earlier this semester. Rule number 1, you can multiply anything you want together. Anything. So if I wanted to multiply 4a times 7b, I can multiply them because I'm going to end up with 28ab. That's my final answer. In the second one, if I multiply a 7x squared and a negative 6x to the third, again, I can multiply anything I want. So that's going to be negative 42 x squared x cubed. Of course, there's a better way to write that. It could just be negative 42x to the 5th power. Same exact thing if I'm multiplying square root symbols. If I took regular 3 times regular 7, I get regular 21. So it makes sense that if I take the square root of 3 times the square root of 7, I get the square root of 21. And if that's written in simplest form, that's my final answer. The only numbers that I can think of that can multiply to give me 21 are 7 times 3, and 7 and 3 is not in my list of perfect squares, so radical 21 is as simple as it gets. Number 4, I can multiply anything I want together. If I take a regular 5 times a regular 8, I get regular 40. If I take the square root of 5 times the square root of 3, I get a square root of 15. So 40 radical 15 is this final answer. Now, if this could be simplified, then I would do that. Numbers that multiply to give me 15, well, 15 times 1 and 5 times 3, none of those numbers, besides 1, are in my list. And so I cannot simplify radical 15, which means 40 radical 15 is as simple as it gets. So the main thing to remember is you can multiply anything you want together. Now, since we don't multiply everything all the time, sometimes we do add and subtract. We need to remember what these rules are. And you can only add or subtract like terms. So, if I take a look at number 5, this is a problem from earlier this semester. I see that I have an x squared, and I have no other x squared term. So I'm just going to write it down. I see that I have a positive 7x and a negative 4x. Those two things have opposite signs, so I need to subtract them, and I get a 3x, positive 3x, because 7x was the bigger term. And then I notice that I have a minus 28 here at the end. I don't have any other number to combine it with, so I'm just going to put it at the end, minus 28. So I simplified it to x squared plus 3x minus 28. Same exact thing happens with square root symbols. Exactly the same thing. I notice in this first one that I have an 8 radical 7 and a positive 9 radical 7. Those are my two like terms. So if I add those together, I would end up with 17 radical 7. And then I notice that I have a minus 3 radical 5. I have nothing to combine it with, so just put it at the end. Minus 3 radical 5. And that expression is as simple as I can get. Last one. Number 7, 10 radical 7 minus radical 7. You might think that this answer is just 10, that the square roots cancel out. That is not the case. Think of this as 10 radical 7 minus 1 radical 7. Then I can subtract these. 10 minus 1 is 9, so I have 9 radical 7s. So the main thing to remember here is you can only add and subtract like terms.